Hello guys, today I'm going to show you how to solve an ordinary differential equation using the Euler method. So let's assume this ODE dy dt equals minus y plus t plus 1 with an initial value of y at 0 equal 1. And we're going to solve this using the Euler method and the step of h equals 0.2. Firstly, let's see how the Euler method works. So let's assume that on this axis we have y and t. We start at t0, okay, in which case it's 0, and y at 0 is 1, as we said. Okay, so these are initial points. So to apply the Euler method, we will need the slope at this point, at point 0, and the step, which is 0.2. So knowing the step, we can find our t1, okay, so it's going to be t0 plus the step, and we're going to use the slope on this point and extrapolate until our next t1. So, using the Euler method, this is the approximation of our next point. We'll call this y1. Now, we proceed with exactly the same approach. We come at point 1, find the slope, okay, and extrapolate until t2. So this here is t2 corresponding to y2. Okay, let's write this down. So the rule we are using is that yi plus 1 equals yi plus the step times the slope of y, I will call it f, at yi ti. So, in other words, the slope is a function of ti yi. But do we know this slope? Well, here it is. Okay, so it's given by this equation. Alright, let's make a table and apply the Euler method for a few steps. Okay, so we'll start with our variable t, okay, our initial point is 0, t0, our next one is 0.2, so 0 plus 0.2, our next step will be 0.2 plus 0.2, so 0.4, and so on, depending on how many repetitions of how many steps we want to do. Okay, so we're going to need the slope f, and we will also need y. So we already know this y here, it's 1, okay? And now let's find the slope here. So it's going to be f0 will be minus y, so minus 1, okay, plus t is 0, plus 1, so that equals 0. So the slope here is 0. So our next y here, okay, actually it would help us if we had the index I here, okay, so this is 0, this is step 1, this is step 2, and so on. All right, so y1 will be, as we said earlier, y0, which is 1, plus h, the step which is 0.2, multiplied by the slope at 0, so f0, which is 0. So this equals 1. Okay, let's find the slope at point 1. So f1 equals, here's our equation for the slope f, it's minus y, so minus 1, plus t, so t is 0.2, plus 1, which equals 0.2. So let's write here 0.2. So what's the value of y2? y2 equals, we follow the rule here, y2 will be y1, y1 is 1, okay, plus the step 0.2 times the slope at point 1, so f1 is 0.2, which equals 1.04. So we write here 1.04. So this is the Euler method, and we can continue as many times as we need to.